So we'll be waiting for 1 or 2 more minutes to other friends to join. Okay, so after that we'll start the class today. And in the meantime, if you have any doubts from the previous classes, you can let me know. If you have any question, any doubt from the previous classes, okay, you can just let me know. I'll be very happy to answer your queries. Okay, and after 1 or 2 minutes, once some more people joins, we'll start the class. Or in the meantime, if you have understood all the previous things, if there is no question, that also you can let me know, so that I can know where to give more stress or whether you have understood or not. So in the previous classes, basically we have started discussing about extrusion process. Okay, we already know what is this extrusion process. Okay, and how is it? How we can compare extrusion process versus rolling process and all. Okay, what are the similarities? What are differences? So in the previous classes already we've seen that basically what we have is we have the container here. Okay, so container, inside of it we take the billet. Generally it is heated metal billet. Okay, and the main thing is that is the whatever is the product shape that we require. Based on that we have to design the die, and this die will be there. The die opening, suitable die opening, we have to design as per the requirement of the product. And after that, once we apply force, compressive force on the heated billet through the help of a ram or a plunger, basically the extruded metal flows through this die opening. Okay, having or getting the with producing the required cross section. Okay, so in that particular case already we have discussed that it's geometry is unsensed throughout the die geometry is unsensed throughout the operation, and because of that product, the extruded part that we get is of constant cross section over the length. Okay, so that is the thing. So already these things already we have discussed. We have also seen how discrete parts we can get from a continuous extruded part. Okay, by cutting it at the required thickness. Okay, similarly we have seen that how very sharp corners can be easily obtained with the help of this extrusion process. Okay, and later on we have already both the extrusion process and a rolling process, we have actually compared them. There we have seen how they are similar, that is the constant section we generally get over the length in both the cases, but the complexity of the parts as well as the amount of reduction possible, these are generally more in case of extrusion process compared to rolling. Okay, similarly sharp corners we can get, and generally it's a single pass process, but mostly the rolling is multi-pass process. So later on we have discussed about how the metal flows in extrusion. There we have seen 3 cases. So and for the low friction case, next one is for high friction case. Okay, and it is for high friction or with cooling of the outer regions of the billet in the chamber. Okay, so there we have seen the dead zone. Okay, where basically essentially the metal doesn't flow and it's kind of stagnant. Okay, and how it deforms, the metal deforms, all those things we have discussed. And we have discussed about the dead metal zone, and after that later on we have discussed about the extrusion ratio, where we have seen that it is nothing but the ratio of the cross sectional area of the billet to that of the extruded section. Okay, and that is nothing but it is the reduction that we get. Okay, and based on the what is the value of extrusion ratio, typical value is 20 to 50, that kind of reduction that is generally achieved. Okay, those things already we have discussed. So today in this class we are going to discuss about the various extrusion classification and some of the variables affecting this particular extrusion process. Okay, so now we already know that in the case of extrusion, basically it's a compressive force that we apply. Okay, we compress that particular billet against the with the help of the ram and against the and through the opening of the die cavity, basically it comes up. So now, depending on the direction of the flow of metal, okay, when we are forcing the when the force is being applied, okay, in which direction or from which direction basically the extruded metal flows, based on that we can primarily classify extrusion process in two main categories. So one being the forward extrusion, also known as the direct extrusion, and another one is the next one is the backward extrusion, also known as indirect or sometimes reverse or inverted extrusion. Mostly the indirect and reverse extrusion, these two process words are mostly used rather than the inverted one. Okay, but all the things all are having the same meaning. Okay, so that is with respect to the direction of flow of metal whenever the force is being applied. Next, once again, just like any kind of forming process, okay, here also based on the temperature we can have cold working, okay, warm working and hot working, and in the case of extrusion they becomes cold extrusion, warm extrusion and hot extrusion. Okay, these things we already know. Okay, next, similarly, whether in which way, in which mode basically the extrusion process has been obtained. So, is it continuous process like or discrete process like that? We can also divide that. Okay, and there are certain other special type of extrusion process like hydrostatic extrusion, cold extrusion forging process, impact extrusion process, etc. Okay, so these are some of the classification of like your extrusion process. Okay, now in the case of extrusion, we have already discussed that the whatever is the shape of the extruded part or the cross-sectional area of the extruded part that we achieve, that is basic primarily or mainly to the whatever is the design that we give to the die cavity. Okay, die opening in this particular case. Okay, so depending on the die design, we can get the extruded part. Okay, so in that case of the already we have discussed that die designing is a very important aspect. Okay, so die has to be properly designed in the case of extrusion, and all the tolerance, etc. It has to be proper. Only then we can expect that whatever is the part that is the extruded product that we get, that will be of proper dimension. Okay, so now some of the main geometric variables in extrusion, okay, which are very important are the die angle denoted by alpha. So in this particular figure, you can see, so we have shown the chamber or the cylinder, okay, this, okay. So inside of it, we have got this particular work material, that is the billet, okay, and at this particular end, we have the die, okay, and this is the opening that is in the die, okay. So now, what is this extrusion angle? So the same, this particular portion has been shown in an exaggerated manner in this particular figure. So this geometrical variable, which is very important, is the first is the die angle. So now die angle is this particular angle. Okay. So this portion, okay, whenever it is the angle, right? Okay. So this particular angle is the die angle. Next, we also have the main variable like influencing your extrusion processes. Another is the extrusion ratio. Already we have discussed about the reduction in cross section. Already we have discussed. So that is the billet area. If you consider this is the cross section area, and in the final extrusion part, if this is the case, okay. So this ratio is nothing but the extrusion ratio, which in this the reduction is in case of extrusion. Okay. So that is another relate, okay, whether it has been preheated or up to what temperature it has been heated. So based on that, basically the strength of the metal will be there, okay, and whether the flowability of the metal, all those things will depend on the this particular temperature, okay, because we already know with the increase in temperature, the ductility really increases, the flow of metal becomes somewhat easy because the strength is now less, okay. Similarly, what speed your the RAM is being traveled, okay, or also known as the extrusion speed, at what speed you are doing this particular extrusion process, okay. So that also influences the extrusion process, okay. Also, in this particular cases, basically in the periphery, okay, that is in the surfaces, contact surfaces where we have got the relative motion, we actually use some lubrication, okay, lubricant. So based on type of lubricant, what kind of lubricant oil you are using, or some other lubricant that you are using, okay, whether solid lubricant, some liquid lubricant, or maybe grade of lubricant, based on all those things, actually the extrusion process also it is one of the another variable, okay. So these are main variables. And similarly, in this particular zone, if you see this particular figure, so you can see that some relief angle also is being provided. Okay, so this is the workpiece. This is this part when this only. Okay, the upper part. Okay, so this is the workpiece. It is coming out. Okay, so this relief angles, this small angle, relief angle, it makes the workpiece flow easier. Okay, coming out of the die cavity. Okay, die opening easier. So this is basically about the different classification of your
স্যার এক্সট্রুশন
extrusion process.
ফুডতো হয় নি?
Yes.
এক্সট্রুশন ফুডতো হয় নেকি?
Yeah. So sometimes some like see, maybe all of you have seen pasta or maybe the chow mein, etc. Yes. So generally those soybean, etc., pasta, different pasta, etc. Actually, they are basically made with the help of this extrusion kind of process only. Okay. So it is right now we are talking about metal extrusion. Okay. So similar is the thing. Actually, we have the die while making the pasta, etc. Okay, and whatever is the dough. Okay, whatever we have that we press it against that particular die, and it generally comes out of this particular die open. Okay, and having required shape. So that is food extrusion. You can consider like that. Okay, but right now we are not interested in the food engineering or food technology perspective, but we are mainly considering about metal extrusion. Okay, so I hope I have clarified your doubt.
Yes স্যার, থ্যাংক ইউ স্যার, ধুনীয়া হৈছে।
Okay.
Sir, who is the new member, sir?
I
Yes.
am the new member. I want to learn things. That's why I came here.
Okay, but where like you are from? Which branch? From mechanical only?
No. I just finished my polytechnic.
Okay, so how did you get the link for today's class?
I won't tell you.
You won't tell me. Okay, then I have to find out. Okay, and if required, maybe. Okay, so if you wanted to learn the things or what?
Yes sir.
Okay, so okay, be with us then. Okay, for some time, don't do the same thing in the classes because I have to those things also because if leaking the class is not that much good. Okay, but anyhow, okay, you are welcome for right now. Okay, so next we'll be basically discussing about the direct extrusion and the indirect extrusion process. Okay, so now already we have discussed that based on the during the course during the travel of the RAM when you apply the force with the help of RAM on the heated bill. Generally, depending on the temperature, it may be heated or it might not be heated. Okay, but we are going to compensate. Okay, so in the case, okay, depending on its your so now uh, in the case of direct extrusion, basically what happens the from the very beginning, whatever actual the diagrams that we are mostly drawing or denoting extrusion process, okay, which you have generally seen, that is the we are mostly drawing the direct extrusion process only. Okay, in the the direct happens, we already know that a metal is generated within the container and we have got the to force it, okay, to compress it, and the ram it compresses the metal. And what basically happens, the work metal it goes through whatever is the number of opening. It may be one opening, just like I have given the example for the food. Okay, there are generally multiple openings in the die. Okay, so one or more openings in that die from the opposite end of the container. So in this figure, you can see RAM is in this side. Okay, it is we are compressing from this particular side. We have got this work billing side. Okay, and we have the die here, and this is the die opening. Okay, and now in the while we are applying compressive force here, so basically in the die the work metal, okay, it has got nowhere else but only to it has to the only option is to come out from this particular side. Okay, that is the normal physics. Okay, so now in this particular cases, okay, so the direction of ram travel and the direction in which the final work shape or final work we are getting, okay, both of them are same. So in those cases, basically it's known as the direct extrusion. Now in this particular case, what happens as the ram approaches the die, a small portion of the billet it remains which cannot be forced through the diaphragm. So what happens towards the end, when the suppose the ram will come like this, okay, next sometimes the portion of the ram will be here, this way it will come out, okay. Similarly, sometimes it will be here and on, okay. But towards the end, there will be a portion. It will be like okay. Hello, everyone. Can you hear me? Sorry for the interruption. Actually, I just got logged out because in college, just electricity was like it was offline. Just for some second, I got logged out. Okay, I'll be rejoining from. I'm just now rejoined from my mobile. So just wait for 1 or 2 minutes. Okay, just bear with me.
Okay, sir.
Sir, I think it's better to kick him out, sir. That Abhijit Bora.
তু কি হলবে?
কোন অভিজিৎ বৰা ইয়াত কোন আছে ওলাই জানি আহিছে
এই তোৰ যদি আছে তো কথা যেনেকে কৈ আছ ন তোৰ নাম চিনাকিটো দে ভালকে যদি তোৰ ইমানেই দম তাৰপিছত দেখা পাম ন
ওলাই গ'ল
ছাৰে উলিয়াই দিলে
অ
একচেপ্ট কেনেকে হ'ল ৰে ছাৰটো একচেপ্ট নকৰিলে হয় বেলেগ নাম দেখিলে
আমাৰ লগৰ কোনোবাই লিংক শ্বেয়াৰ কৰিছে আকৌ
ऐसे वैसे ऐड मत करो रे अरे ऑटो एक्सेप्ट है इसलिए ऑटो एक्सेप्ट तो मतलब ऐसे কৰিব লাগিব ফাৰ্স্ট টাইম एक्सेप्ट কৰিলেহে সেকেন্ড টাইম वो लिंक ऐसे मत दे
I request now. See, the thing is, I think I was on mute because of that. You couldn't hear what I have said. Okay, so please, nobody should share the links to outsiders. Okay, it's only for you people. Please don't do that. Okay, because only some of you have shared with he may be your friend or I don't know. Because of that only he could get the link, and because of that only he was like here. And as initially he said that he wanted to learn thing, and because of that he was there. So for today's class, I actually like being sympathetic. I can say it was my good gesture. Yes, yes. Yes, that I could understood. But as he introduced himself as student, like, and some of your friend only, because some of you have actually shared the link. That's why only he could get it. Because of that, only for today's class, I actually allowed him. It was auto allow also. Yes, that's why I have removed him. Okay, but I request everyone not to share the links with outsiders. Can I get a affirmative reply from all of you? Okay, thank you. I am relying on you people, so don't make me look fool. Okay. Okay, so now in this case, so direct extrusion, what basically happens? So here you can see the direction of ramp travel and the direction in which the final workpiece is coming out, they are same. So that is one of the characteristics of this direct extrusion. Okay, so now in the case of this direct extrusion, as we have seen, towards the end of the extrusion, a small portion of the billet, it remains, which cannot be forced through the die opening. And that particular extra small portion is known as the butt. So butt formation, it's a process. It's a characteristic of direct extrusion, and this is kind of the extra portion. It becomes the wastage. Okay, and generally this particular last portion is separated from the product by cutting it just beyond the exit of the die. So when it comes out of this particular die, basically we trim it off. Okay, so that is basically about direct extrusion. Now, as you can see, as whatever that figure that we have discussed, this is a direct extrusion for getting solid cross section. So as you can see, if you have one single opening or maybe multiple opening like this, then through the opening, the whole material is going to come out, and the product that we get will be a solid product. Correct? I hope all of you can get me. Okay, so that is about solid product. But it's also possible to get hollow cross section. It's also possible to get hollow cross section in the direct extrusion, or maybe in indirect extrusion also. So for doing the hollow cross section, what we have to do, what is the modification? So now in that case of opening of the billet, okay, opening of the die, okay, what we will do, we can add this mandrel inside, solid mandrel inside, which is just like the core. Okay, if you recall core from the casting, okay, so but here also you can consider as if that is a core like thing. Okay, we can insert a mandrel here, solid mandrel here. Then what will happen, whenever we are actually forcing that particular, rest is similar, whenever we are forcing with the help of this particular ram, okay, the workpiece gets compressed and it comes out of this particular die opening. But in this case of die opening, basically this particular portion, as we have the solid mandrel here, this part from this particular portion it cannot come out, but from this location, the upper portion, and this location it will come out. So whenever the final cross section that we will get, that will have this blue part as the hollow part. Okay, so that is the way we can get hollow cross section in the direct extrusion. And now, depending on, as we already know, the shape of this particular, whatever the final cross section in the extrusion that we get, okay, so that shape, it's possible to get multiple shapes, different shapes. Just the thing is, you just have to have a solid die of that kind of shape. So in that particular case, these are the different cross section that has been shown, maybe circular, square, that kind of thing, C kind of thing, bracket kind of thing. Okay, so everything is possible. So in that particular case, if this is hollow, okay, so if that case, then a mandrel of this kind of solid shape, circular cross section, we have to insert. Similarly, if you want this kind of cross section, then the opening of the die opening should be like this. Okay, and this portion, as it is hollow, you have to insert this mandrel, okay, or a core like thing, solid core here. Similar is the case with this. You may have this kind of opening, and maybe the shape itself may be like this, or maybe the Mandel shape may be like this, okay, or already the whatever is the way you design, okay. So all these things are possible, okay. So I hope you have understood. Now there is one problem with direct extrusion. What is the problem? Basically, it is associated with very high friction, which exists between the work surface and the walls of the container. Because we have seen that this particular this billet is forced through slide along the die opening and the area of this particular surface of this particular container, okay. And because of this, as it is associated with high you can say high amount of frictional force, okay. So because of that, the friction causes a substantial increase in the ram force required for doing the direct extrusion. Because we already know we have to apply force to compress this particular metal, okay. Metal compression is not that much easy. You have to apply high force, and now as it is associated with high friction, once again the force requirement it increases, okay. So this is all about direct extrusion. So I hope you have understood about direct extrusion. Just let me know. Okay, thank you. So next we'll be discussing about the indirect extrusion. Okay. So now what happens? How the indirect extrusion and direct extrusion they differs? Okay. So basically the difference is, already I have said that it is with respect to the direction of the like movement of this particular relative movement of the particular ram movement, and with respect to the work like whatever is the part extruded part that we get. Okay. In the previous case, the direction of ram was like this, and from this side only, as we had the die opening here, okay, here we had the die opening, okay, in this rotor. So this way we got this particular of like extruded part. That was about with respect to direct extrusion. Now in the indirect extrusion, basically what happens here, the die is mounted on the ram itself rather than at the opposite end of the container. So this itself is the ram, and depending on whatever is the cross section you require on the part, so that way on the ram itself will have this die opening, okay. The ram itself will act as a die opening, okay. And now because of that, what will happen, as the ram penetrates inside the work, so it is going in this particular direction, right? The ram is moving in this particular direction. We have the container here, and we have got the heated billet here, okay, work billet here. It may or may not be heated, okay. Now because of that, what will happen, as now the your die itself is mounted on the ram, okay. So what will happen if we move the ram in this particular direction, okay. So this work billet will get compressed, okay. Definitely it will get compressed as we are moving in this particular direction. But after it reaches a particular compression, what will happen, the metal will come out in this part or flow in this particular direction through this die opening. So now as you can see, the movement of the ram and the direction in which the work material is coming out, that is the extruded part, both of them are different, opposite. So that's why it is nothing but the indirect. Okay. So now whatever is the clearance given here, based on that, through that particular clearance, okay, which itself is the die opening, your that particular work will come out. Okay. Now here in the previous case, what we have seen, okay, the billet was forced to move relative to the container in the previous case, okay. But here we can see that the billet will move like this only, okay. So work material will like this. So now since the billet is not forced to move relative to the container, so there is basically no friction at the container, or you can say very negligible friction, and therefore the ram forces in case of our indirect extrusion is considerably lower than that of direct extrusion. That is the primary reason. Okay. Now once again, this particular, with the help of this indirect extrusion also, we can go for solid cross section, also we can go for hollow cross section. So solid cross section one will get whenever this way we will have the opening only without any insertion, okay, then we'll get the solid insertion, okay. But sometimes what may happen, if this is the dimension of the container, that is the diameter, okay, and this is the, you can say you have this particular ram here, and maybe this way it is the ram, okay. So in that particular case, if you apply force like this, okay, then what will happen, the material will come flow from this location, okay, and this portion will be hollow. Okay, so hollow cross section also we can get with the help of indirect cross extrusion also. Okay, but there is one limitation of indirect extrusion, and this particular limitation is imposed by the lower level of rigidity of the hollow ram and the difficulty in supporting the extruded product as it comes out of this particular die. So that is the main limitation. And as we are already using the ram itself, okay, and the ram is already, you can see in the ram itself we have got the die cavity. It itself is acting like die cavity, so it becomes a hollow. Okay, so because of that, basically rigidity of the ram itself gets somewhat diminished. Okay, and because of that, some problem is there. That is the main thing. Okay, and as we have discussed, indirect extrusion can also produce hollow or tubular cross section. Here the ram is pressed into the billet and forcing the material to flow around the ram, and it takes a cup shape. You can see from here. So when it comes around this particular ram, so it will look like a cup shape. So that means this particular portion is hollow. Okay, and this will come like this. Okay, so this is basically about indirect extrusion. All of you have understood or not? Just let me know. Okay, thank you. So what's the main difference? That means it is the main difference with respect to the direction of ram movement and the direction of your the extruded part movement. Okay, so basically based on that we have got the direct and indirect extrusion. Okay, next we'll be discussing about a specific type of extrusion, that is the hydrostatic extrusion. So as the name itself suggests, hydro word is already there. Okay, so you can very easily understand that some fluid force or fluid will be involved in the extrusion process. Okay, so some motivation definitely will be there. Okay, so now what we have seen in the case of our direct extrusion, we have seen that basically direct extrusion is somewhat good because the rigidity of the ram itself, it is okay, it's good, and after that whatever is the movement dimension, or you can say design that you give in the die, based on that you are going to get the product. But we have seen that error, it was friction force was there. Okay, and because of that high pressure was required, ram pressure, etc. Those are the main problem. Okay, so now the problem of friction along the billet in the case of direct extrusion, it can be addressed by surrounding the billet with fluid inside the container. Okay, so here you can see this particular case, okay, how it is different. So it is the container. Other setups is somewhat similar. So we have got the die opening and all, die and all. Okay, we have got the ram, but right now surrounding this particular work billet we have got a particular fluid, okay, a particular viscosity, particular for different applications. Okay, so now the billet is fluid, it is surrounded by surrounding the billet with fluid inside the container, and now we pressurize the fluid by the forward motion of the ram. Okay, so now what we do, the ram is not in direct contact with the billet, but it is we have got the fluid here. Okay, and we already we pressurize the fluid, and we already know about all those Pascal's law and all. Okay, throughout at each and every point basically the pressure will be same. Okay, same pressure will be there, and basically that particular pressure will be responsible to pressurize or compress this particular work billet. Okay, now you can see basically we have eliminated all the contact with of the billet with the actual metal to metal contact we have removed, right? Rather now the billet is inside this particular billet is being surrounded by a fluid. Okay, and now this particular type of extrusion process is known as the hydrostatic extrusion. Okay, so now you can see there is no metal to metal contact, etc. So there is no friction inside the container, and the friction at the die opening also is reduced. And now if there is no friction in this particular, main friction itself is being reduced. So because of that, definitely the ram force that will be required will be definitely very less than that of your direct extrusion. So the ram force is significantly lower than that of the direct extrusion process, because where there is no contact, etc., metal to metal contact is not there. So because of that, there is no you don't have to overcome the frictional force to compress the metal, and if that is the case, then with the application of less amount of force also we can do the same task. Okay, and now Now, this particular process, it can be carried out at room temperature also, maybe some elevated temperature also you can do, depending on the whatever is the fluid that we are using. Okay, it should not decompose at that particular temperature, or maybe its other effects. There should not be any harmful effect with this, with respect to this particular fluid at the temperature. So based on the capability of the fluid, etc., we can go for room temperature or at elevated temperature. And if we are talking about doing the hydrostatic extrusion process at elevated temperature, definitely we have to take take the help of special fluids and different special procedure. Okay, so that there is no like you can say decomposition of the fluid, or maybe it will not become reactive, or it will not erode that particular work material or the other surfaces, etc. Okay, so these are the things. And as you can very easily see, it's nothing but an adaptation of the direct extrusion only, but here direct contact is not there. But just like in the direct extrusion, here also the ram movement direction and the extruded part movement direction, okay, it is same only. So we can say that it's a kind of adaptation of this direct extrusion process. But very easily all of you can see, that means there will be some problem here also. Okay, so what is the problem? Okay, so see, as we're talking about using the fluid, etc. So sealing is one of the main problems, sealing the fluid inside it. So all those, there should be properly sealed. The container should be proper. We have to look for all those, whatever is the like, if there is any clearance, etc. All those things we have to look for. Okay, and now what are some of the advantages? So because of this hydrostatic pressure that we apply on the work, so it increases the material's ductility. And if that is happening, then this particular process is suitable for metals which are generally too brittle for normal conventional extrusion operation. So we can work with metals which are somewhat brittle, okay, more brittle, which cannot be easily handled by conventional direct or indirect extrusion with the help of this hydrostatic extrusion. Okay, so that's the main thing. Next, apart from this sealing, there is another disadvantage of this process, which is the requirement of preparation of the starting work billet. So that is also related with sealing, also proper sealing. So the billet in this particular case, the billet, it must be formed with a taper at one end, as you can see here. And the fitting of the billet, with respect to the die, should be snug fit. Okay, that means there should not be any. It's like just like exactly whatever is the this portion. Okay, both the mating portion, actually there is no clearance and all. Okay, properly it is being fitted, so that is known as the basically snug fit. So that is basically about all hydrostatic extrusion. So you have to be careful enough so that there is no leakage and all. But there are advantages associated, like low amount of force will be required for compressing it, and similarly you can get different more brittle material also can be done. So I hope you have understood hydrostatic extrusion. Let me know. Okay, we just have 2 more topics so that we can cover today. I think at 12:05, do you have any class from 12:05? 12:05? Okay. So, okay, no problem. It's very small only. So, next is impact extrusion. So, like impact extrusion, as the name itself says, that is impact loading we are going to use. So, this impact extrusion, it is performed at higher speed and the shorter strokes compared to your conventional extrusion. Okay, like all those making up all those single individual components, discrete components like toothpaste tubes or something else. Okay, so we can go for this impact extrusion. That means in a single extrusion, single discrete parts. Okay, so as the name itself suggests, impact word is there already. Yes, so the punch, there will be a punch that impacts the work part rather than simply applying pressure on it. So in the previous case, what happened? We had got the ram and all. Okay, gradually we were applying pressure. Now here we'll be applying impact loading. Okay, and just like in the case of other cases like forward extrusion, backward extrusion, etc. Okay, so here also impacting can be carried out just the way we have done for forward extrusion, revert extrusion, etc. And in our case of impact loading, basically backward extrusion or backward impact extrusion is 4:1. And what is the advantage? We can get very thin walls with the help of impact extruded part. So these figures are self-explanatory. You can very easily say So one, this shows the forward extrusion, this shows as the reverse extrusion. So what you can see, basically now the punch will not be in direct contact with the die. Okay, so die will have the record shape and will have the workpiece here. So we'll be doing impact loading here. Okay, so next second figure you can see when it has been impacted. So what will happen? This way, the blue part that becomes the extruded part. So this is forward extrusion. So this way it is applying the force, and this way we are getting the in the same direction we are getting the output. And we can also have backward extrusion. So we'll have the starting blank here, the punch. Okay, we are going to apply impact loading here, and there will be this clearance will be there in between the that we have to design properly. And now what will happen when we impact it? Okay, force it through, then the metal will flow through this particular clearance in the opposite direction. So that becomes backward extrusion. I hope it's clear. Just let me know. And we just have the last topic. And so we must know about the ram pressure versus or ram force versus the ram stroke. Okay, how the pressure varies, ram pressure varies with the help of ram stroke. So now this part main thing is ram force. What is the ram force that will be required? Okay, so that you can very easily get from this particular F. We already know P equal to F by A. From there itself we can get the F equal to P into that area. Okay, pressure into that area. So from there we can very easily get. Okay, so what happens how there, if you just look at this particular figure, so in this x-axis we are showing the ram stroke, here ram pressure. So we'll be showing for direct extrusion and indirect extrusion. Okay, so what basically happens, we already know in the case of direct extrusion the force requirement is more. Okay, so that pressure rises more rapidly here and the requirement of pressure is more, okay, than that of indirect extrusion. Okay, and after it has been compressed, a sufficient level of pressure has been obtained, then only the actual extrusion will begin. Okay, from here, not from the zero. Okay, so after that what happens in the case of direct extrusion, generally it gradually comes down, and in the case of indirect extrusion, as there is no friction etc., it once the force has been built or the pressure has been built up, so it will remain static there. And at the end of the process, basically towards the back formation, we have seen that there is at the end there is something will remain. Okay, some portion will remain because of which cannot be extruded. So at the end, once again with the dotted line, what we are seeing, during when the back formation is happening, once again the pressure will rise. Okay, so that is the variation of the ram pressure or ram force with ram stroke. So this way it is showing ram stroke, that means how the stroke is involving, or in this way if you direction, if you say, it is the remaining length of the billet to be extruded. Okay, so up to this much, that means it is the whole billet is remaining for extrusion. Up to this much, that means half of the billet has been extruded. Only next this much will remain for extrusion and this much will remain, that is nothing but the back formation. Okay, so this is basically about the graph. Okay, and the shape of the initial pressure build-up at the beginning of the plot, it depends on the die angle. And as we have already discussed, die angle is one of the variables. So higher die angles, it causes steeper pressure build-up. Okay, and at the end, the pressure increase at the end is basically related to the formation of the bar. So with this, basically we have completed today's class, and there is some drawing operation, deep drawing, wire drawing, rod drawing, etc. So you can just, it is a very simple only, you can just go through it and you can submit as an assignment. Okay, so this is your task. So with this, basically we have completed our this particular part from this module, and we'll stop here, and we have basically ended this particular part from this module. And if you have any question, you can let me know. If you have understood, then also you can let me know. I'll stop there only.
Thank you, sir.
Okay, thank you.
Thank
So
you,
if you
sir.
don't have if you don't have any more question, then we'll stop here. Thank you everyone for joining, and I request all of you not to share links with outsiders. Thank you everyone. Okay, I am stopping the meeting here.
Thank you, sir.